Hi everyone, I'm Cheryl. In this problem, we want to represent our planar curve x squared plus y squared equals 25 using a vector-valued function. Now, an interesting thing to note is that there are many correct answers to this problem. Well, let's go ahead and try to get at least one. So I'm going to take a look at x squared plus y squared equals 25. And I'm going to make use of the Pythagorean theorem because I know that the cosine squared of t plus sine squared t equals 1. This looks very similar to the problem that I was given. In fact, if I multiply both sides of that equation by 25, I get 25 cosine squared t plus 25 sine squared t equals 25. And now I notice that I can let 25 cosine squared be x squared and 25 sine squared t be y squared. That means I'm going to let x equal 5 cosine t and y can equal 5 sine t, which means for my vector-valued function, I can write r of t equals 5 cosine t times vector I plus 5 sine t times my vector j. Okay, now I mentioned that there were more than one correct answer here. Notice that I could have chosen x to be a negative 5 cosine t, or I could have chosen y to be negative 5 sine t, or I could have chosen both of them to be negative. Any of those options would work. And when I originally chose my Pythagorean theorem, I wrote it as cosine squared t plus sine squared t equals 1. I could reverse that and make it sine squared t plus cosine squared t equals 1. All of those options will give me a slightly different vector-valued function, but it'll all represent the same curve. Now let's go ahead and take a look at what this looks like on my Cartesian plane. If I look at this vector-valued function, remember the tip of the terminal point of my vector will trace the curve. So let's start out with t equals 0. The cosine of 0 is 1, and 5 times 1 is 5. So I'm going to have I, and the sine of 0 is 0. So that's going to give me a vector of length 5 right along the x-axis. Let's try another point. Let's say pi over 2. At pi over 2, the cosine of pi over 2 is 0, which knocks this term out, but I have a 5j, and so it's going to be this vector. And I can continue doing that, but remember what I'm doing is the tips of these vectors are tracing out my curve. And if I continue taking test points and continue putting in different values of t, I'm going to find out that I get a circle of radius 5. Now the other thing that's kind of interesting to notice is that I can also take my vector-valued function and restrict the domain of t. I can say that t has to go between 0 and 2 pi. That way, the tips of my vectors are tracing the circle only one time around. If I don't have that statement, I continue to go around and around, both in a counterclockwise direction and in a clockwise direction. I hope that was helpful. Thanks.